In this lesson, we'll talk about statistics, and specifically we'll be talking about measures of central tendency. So here are our objectives. We're going to interpret the elements of data sets presented in different frequency distribution formats. These include lists, tables, stem and leaf plots, frequency histograms, and frequency polygons. Then we'll determine the mean for a data set. We'll also determine the median for a data set. We'll talk about the mode for a data set. And we'll talk about the mid-range for a data set. Now, a data set may be presented in a list form, such as the list of numbers you see here: 72, 91, 46, 88, 83, 77, 61, 95, 81, 66, 75, and 81. Data can also be presented in what is called a frequency distribution table. So here we have from 90 to 100, 2, from 80 to 89, 4, from 70 to 79, 3, from 60 to 69, 2, 59 or lower, 1. Once you know the context that these numbers are representing, you'll understand more about what these tables and lists mean. Another way that data can be displayed is in what is called a stem and leaf plot. In the first column, you have what is called the stem, and in the second column, you have the leaf. In our stem column, we have 4, 6, 7, 8, 9. In our leaf column, we have a 6, then we have 1 and 6, we have 2, 5, and 7, followed by 1, 1, 3, 8, and then by 1 and 5. And while it might be difficult to see at first, this means the same as 72, 91, 46, 88, 83, 77, 61, 95, 81, 66, 75, and 81. And we'll talk about why in just a minute. This is what is called a frequency histogram, also known as a bar graph. Along the x-axis or horizontal axis, we have 90 to 100, 80 to 89, 70 to 79, 60 to 69, 59 or below. And now we have a little more information that these are grade ranges. And then on the vertical axis, we have number of grades in that range, ranging from 0 up to 5. And we have a title that tells us that these are final grades earned in Math 1101. So if I were to look in the 70 to 79 range, I could go across and say, well, there were 3 grades earned in 70 to 79 range. So for example, these may be the final grades of a class that I'm teaching, and 3 students would have earned a C in this case. So this histogram means exactly the same as this table representation of the data, where you see 90 to 100, there are 2 scores, and when you look at the bar in the histogram from 90 to 100, the frequency is 2. From 80 to 89, the frequency is 4. 70 to 79, it's 3. 60 to 69, 2. And only 1 grade, 59 or lower. So what you see here is the same data set represented in 2 different visual formats. Data can also be represented in a frequency polygon, and this should be the word polygon, not histogram. And the reason it's called a polygon is if I were to draw in this right here, this is a polygon shape. 1, 2, 3, with 5 sides, so it's a trapezoid of some sort. And we really are only interested in those same heights that we looked at before, and you can see that in the 90 to 90 range there are 2, 80 to 89 there are 4, etc. So this also represents the same data set, and that is the final grades in a class. So I could look at this and say, okay, the final grades from 80 to 89, there were 4 of those. So same data set, different representation, and you're going to see these presented in different formats at different times. And regardless of the format that the data is given to you in, it's always useful to know how many numbers you have. And so in this list, I'm going to go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this is going to be useful for a couple of reasons. And I'm going to go ahead and just note n is 12 because later on when we start looking at some formulas, n is going to represent the number of points in our data set or the number of numbers in our data set. Now if I want to write these in order from least to greatest, it's also useful to have the number that I'm looking for to make sure that I have written them all down. So I'm going to start with the smallest one, which looks to be 46, and I'll mark it out just to be sure that I don't duplicate something. I'm going to go through my list. It looks like 61 would be the next smallest, followed by 66, then 72, 75, 77, and I see that there are two 81s in my list. I must list both of them. And I see an 83, and 88. I also see a 91 and a 95. By marking them out, that helps me not duplicate one. It also helps me to make sure I have them all, but it never hurts to go back and count these numbers to make sure that you have exactly 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my list of numbers from least to greatest. And having the numbers in order from least to greatest will be helpful to us when we do several things with the data set. Let's take a look at this stem and leaf plot. Now, believe it or not, the stem and leaf plot represents exactly the same set of numbers. And here's how it works. The stem is 4, the leaf is 6. That means 46. That was our smallest number in our list when we went from smallest to greatest. Our stem of 6 says 61 and 66. So this is helping us to write out the list from least to greatest, 61, 66. And then I can continue and see that I have 72, 75, 77, 81, 81, just like before, the 81s are repeated, 83, 88, 91, and 95. So in a stem and leaf plot, the stem's going to be the first number, the leaf is going to be the second number. Now, as we start to talk about measures of central tendency, what we're trying to do is characterize the general behavior of the set of numbers, and we'll look to these central tendency measures to help us do that. There are several different measures that we can look at, and the one that we really need to use will depend on certain things about the data set. So we've got mean, median, mode, and mid-range that we want to look at for our data sets. Now, you are going to see some statistical formulas, and you need to recognize a few symbols that are represented in these formulas. The first one being sigma, that's this Greek letter, looks like a big E, and it means to sum. So whenever you see this symbol, it means we're going to add up all the numbers in the data set. The variable x will stand for one individual piece of data. So like the number 46 would be one of the values of x, and x will have multiple values. And the number of x's that you have depends on n, the total number of items in the data set. And f means frequency. The frequency is the number of times a value appears in a data set, such as that value 81, which occurred twice. So we'll see some other ways that we'll use frequencies to help us find those measures of central tendency. So sigma, variable x, n, and f. Sigma means add them up. X stands for an individual item in the data set. N is going to tell you how many numbers you have in your set, and F means the number of times that the number occurs in the data set. So we'll start with the mean. This is the most common measure of central tendency. Your teachers will use in your classes often the measure mean to sort of describe, your general outcomes in the course. What was your average or your central behavior? Did you make mostly A's, mostly B's, C's, that sort of thing. We often use what's called a weighted average, which is a little bit different than the mean, which is a strict average. And the way you find this typical mean or average is you just add all the numbers up and you divide by the number of items in the data set. So that's why we have the sigma x, because remember sigma means sum or add. X means the individual elements or the individual numbers, and n says divide by the number of numbers that you see. And often you'll see x bar, and that is a commonly accepted name for the mean. So that is the sum of all the x's divided by the number of numbers is x bar, or the average or mean. So we're going to use our formula to find the mean, and here we have our stem and leaf. So we've got 46, 61, 66, 72, 75, 77, 81, 81. This is the same exact data set we had before. 83, 88, 91, and 95. And the first thing we're going to do is take out a calculator and add all these numbers together. So I'm just going to take my numbers. 46 plus 61 plus 66 plus 72 plus 75 plus 77 plus 81 plus 81 plus 83 plus 88 plus 91 plus 95. I'm going to get my sum, and my sum happens to be 916. And there are 12 items. Remember, we counted before that there are 12 items in our data set. So we'll take our 916 and divide it by 12. So divided by 12, and we'll get the average or mean of this set to be 76.3 repeated, and depending on the number of places that you're asked around to, we'll say it's approximately 76.3. Now sometimes we'll have a frequency histogram or a frequency polygon. And in the case of these, this F is going to come into the formula, because you're going to know how many times you have a particular response or a particular item in your data set. So in context, here's what we're describing. A small group of students was asked how many email addresses they had, and the histogram and frequency polygon show the responses, and these describe exactly the same thing. They're just written in two different formats, and you're asked to find the mean. Now notice, there are 4 people who responded to 1. There were 8 people who responded to 2. There are 4 people who responded they have 3 addresses, and there are 2 people who responded they have 4 addresses. And you get the same thing here, 4 with 1, 8 with 2, 4 with 3, and 4 with 2. So it's exactly the same thing. So we're going to use our formula here that says take the sum of the individual responses times their number of times or frequency that they occur, divide all that by the number of responses or the number of items in the data set. So we have 2 things here. We have the number of addresses or the number of email addresses that they were asked. How many email addresses do you have? And there were 4 distinct responses. Some had 1, some had 2, some had 3, and some had 4. And the bars in the histogram represent the number of students who said that they had 1 email address, 4. 2 email addresses, 8. 3 email addresses, 4 people said they had 3. And then 2 people said that they had 4. So that's what's going to go in our second column here. And that's responses, or number of students. So the first thing I like to do is find my N. Remember, that's the number of responses we had total. We had 4 plus 8 is 12, plus 4 is 16, plus 2 is 18. So 18 students responded to the survey. Now, this table, or frequency table that we have here, is the same as listing out, well, there were 4 people who said they had 1. List out 4 ones. And then there were 8 people that selected 2, so we could list out 8 2s. And so on. So we could go on and list out 4 3s and 2 4s, or we could use our formula that says take the individual data and multiply it by its frequency. So over here, I'm going to put XF. It's going to be X times F. Number of email addresses, 1, 4 people responded. That would be 4. 2 times 8, 16. 3 times 4 is 12. 4 times 2 is 8. And now sum those up. Remember, the sigma says sum up that product of the number of email addresses times their frequency. We'll put a little line here and add these guys up. It's going to give me 40. 4 and 6 is 20. 12 and 8 is 20. That adds up to 40. So my final result is going to be this sum divided by the number, which we counted to be 18. So 40 divided by 18 is going to be the average number of emails that the students had, which comes out to about 2.2. The 2's repeated, so rounded it would be 2.2. And so you can see there are more students who responded too, so it makes sense that this average is somewhere in the 2 range. Now we're going to talk about the definition of median. The median is a number located exactly in the middle or center of a data set. If a value is the median in a data set, that means that there are exactly as many numbers in the set that are less than this median value as there are numbers in the set that are greater than the median value. To find the median, we must list the numbers from least to greatest, and then find the one that's located directly in the center of the set. If the number of elements in the set is odd, the median is going to be a distinct value, because you'll have the same number of numbers below and the same number of numbers above, and then you'll have that number right in the middle. However, if the number of elements in a set is even, you're going to have to find the average of the 2 numbers that are located in the middle, because there won't be a distinct number. So let's look at one like that. Once again, here is where we need to have the numbers listed from smallest to largest. I'm just going to go through this again. This is the same data set. This is the same data set we've been looking at. Now, the number of numbers we have this time, 12, so I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, is not really needed when we find the median. But it does tell us that when we find the middle or the median of our set, we're going to have the average of the 2 numbers to be the median. So since there are 12, the middle of that would be 6. So we're going to draw a line at 6. Now, if there was an odd number, if there were 13, there would be a number here. That would be your median. But since it's an even number, we have to take the 77 and the 81 add those together and divide by 2. So in our numerator, we get 158 divided by 2, which is going to be 79. So 79 is our number that is our median. There are 6 numbers above that median. There are 6 numbers below that median. Now, if we had an odd set, let me just do a small odd set here. Say this was our list of numbers. 1, 2, 3, 4, 5. Well, because it's odd, that number in the middle is 3. There's 2 below and there's 2 above, and there's no need to take an average. But when you have an even number of items in your data set, you have to take the average of the 2 that are in the middle, so that there will be 6 above that average, 6 below that average, and that number is in the middle of the numbers, and it's called the median. Now, the mode of a data set is the number or numbers that occurs most frequently, so keep in mind that mode equals most. And all we have to do is find the number listed in the set the most number of times. So the mode for our first set here is 81. It is the only number in the set that occurs more than one time. It may be that you have more than one number that occurs more than once. Such as in this set, 72 and 81 both occur 2 times, and so those are called the modes, 72 and 81. And this is a set of data that's called bimodal, because there are 2 modes. Now, it is completely possible that there are no repeated values, and if there are no repeated values, there's no mode. But the one that occurs in the list most frequently is your mode. And the last measure we want to look at is the mid-range. And the mid-range of a data set is simply the mean, or the average, of the largest and smallest values in the set. So what's the mid-range of a set that has a lower value of 46 and an upper value of 95? Just add these numbers together and divide by 2, since we only have 2 numbers that we're averaging. So divide our 2 into 141, and we get that our mid-range is 70.5.